Hi, my name is Karina Plancard Soto, and our group project topic is Newton's Law of Universal Gravitation. This law, developed by Isaac Newton, explains how every object with mass attracts every other object with mass through the force of gravity. The strength of the gravitational force depends on the masses of the objects and the distance between them. This concept is important because it helps explain planetary motion, satellite orbits, and many other phenomena in physics and astronomy.
I'll be going over 1.2 relevant formulas. This slide shows several important gravitational formulas developed from Isaac Newton's work. The gravitational field strength equation is used to measure the strength between gravities between objects. The weight equation, weight equals mass times gravity, is used to calculate the weight of an object near Earth's surface. The slide also includes the gravitational potential energy equation and Newton's law of universal gravitation. These formulas help scientists calculate gravitational force, stored energy, and how massive objects interact with others in space. So 1.3 relevant fields thoroughly described. Newton's law of gravitation is important in several scientific fields, especially physics and astronomy. In physics, the law helps scientists understand how masses attract each other and how forces affect motion. In astronomy, gravitation explains planetary orbits, the motion of moons, and the behavior of galaxies and stars. This law is also important in mathematics, engineering, and space science. Scientists and engineers use gravitational calculations when designing satellites, spacecrafts, and space missions. These fields rely on Newton's law to better understand motion, force, and objects in space.
For this section, the main scientist connected to Newton's law of universal gravitation is, of course, Isaac Newton, who officially developed and published the law in 1687 in his book Principia Mathematica. Newton built his ideas from the earlier work of scientists like Galileo Galilei and Johannes Kepler. Galileo studied how objects fall and discovered that motion follows mathematical patterns, while Kepler explained how planets move in elliptical orbits around the sun. Newton connected these ideas and realized that the same force causing objects to fall on Earth also keeps planets and moons in orbit. By applying mathematics, Newton showed that gravitational force decreases as distance increases, which becomes known as Newton's law of universal gravitation. So, for the original experimental process, scientists studied the motion of planets and objects in space to better understand gravity. Isaac Newton used observations from earlier astronomers, especially Johannes Kepler, to help develop the idea of universal gravitation. Newton compared the motion of objects on Earth, like falling apples, to the motion of the moon and planets in space. Through mathematical calculations and observation, he concluded that the same gravitational force affects all objects with mass. This led to the development of Newton's law of universal gravitation, which explains how gravitational force depends on mass and distance between objects.
2.2 Difficulty/complications. Using Newton's law of universal gravitation can become difficult when multiple objects interact at the same time. Calculating the total gravitational force between planets, moons, and stars can become very complicated. Small mistakes in measuring distance or mass can also cause large errors in calculations. Another challenge that is Newton's law is not always completely accurate in extreme conditions, such as very strong gravitational fields or objects moving at very high speeds. In those situations, scientists use Einstein's theory of relativity for more accurate results.
The motivation behind studying gravity was to better understand how objects move both on Earth and in space. Scientists wanted to explain why objects fall toward the ground and why planets remain in orbit around the sun. Isaac Newton was motivated by observations of motion and the work of earlier astronomers like Johannes Kepler. By studying patterns in planetary movement and applying mathematics, Newton aimed to discover a universal rule that could explain gravitational attraction between all objects with mass.
Right, so minor ejected 2.4 original benefits of discovery discussed. Newton's discovery of law of universal gravitation helped explain how gravity affects objects on Earth and in space. The law explained why objects fall towards Earth and why planets orbit the sun. This gave scientists a better understanding of motion and gravity throughout the universe. The discovery also helped scientists predict the movement of planets and other celestial bodies more accurately. Newton's law became the foundation for classless physics and replaced many earlier ideas about gravity with a mathematical and scientific explanation. 3.1 Modern experiment process described. Modern experiments involving Newton's gravitational consists focus on improving accuracy and reducing errors. Scientists use advanced tools such as torsion balance experiments to measure gravitational forces more precisely. These experiments help researchers better understand gravity and improve scientific measurements. Scientists also compare results from different experiment methods to reduce certainty and improve accepted value of gravitational constant, known as G. These modern techniques continue to improve gravitational research and scientific accuracy. 3.2 Differences in modern approach outline. Modern scientific methods for studying gravity are more advanced than Newton's original approach. Newton mainly relied on observation and mathematical reasoning, while modern scientists use advanced technology and precision instruments to measure gravitational forces more accurately. Today, computers and digital tools help scientists collect and analyze more data precisely. Modern scientists also account for errors and uncertainties more carefully and may use more advanced physics, such as relativity and studying extreme gravitational conditions.
One modern benefit of Newton's law of universal gravitation is that it allows scientists and engineers to accurately predict the motion of planets, moons, and satellites. This discovery is important for modern technology such as GPS systems, satellite communication, and space exploration. By understanding gravitational forces, scientists can calculate orbits and safely launch spacecrafts into space. Newton's work also created a foundation for later scientific discoveries in physics and astronomy, making it one of the most influential scientific theories in history. Future research related to Newton's law of universal gravitation is expected to improve our understanding of space, black holes, dark matter, and gravitational waves. Scientists continue to study gravity using advanced technologies such as space telescopes and satellites. Researchers also use modern physics theories, including Einstein's theory of relativity, to explore situations where Newton's law may have limitations. In the future, continued research on gravity could help improve space travel, satellite systems, and our understanding of how the universe was formed.